video of a 10-part web series on the PPILOW project. PPILOW means Poultry and Pig Low Input and Organic Production Systems Welfare. The main objective of the project is to co-design innovations to improve the welfare of poultry and pigs raised in organic and free-range production systems through a multi-stakeholder approach implemented by 23 partners in 9 European countries. Today on this video, the focus will be on the use of phytotherapy against microorganisms and parasites of traditional pig breeds. With the development of organic agriculture and the multiplication of drug-resistant strains of bacteria and parasites, the use of plants to control parasites and microorganisms in farm animals is being actively researched. Also called phytotherapy, the use of medicinal plants could be an alternative to the use of anti-parasitic drugs in the fight against these sources of diseases in farm animals. This new alternative has been booming in recent years because of the advantages it gives. Indeed, it is biodegradable, permits a decrease of toxicity in treatments, and had quite a few environmental benefits. Moreover, it is a more efficient way to fight against the already existing resistant strains and the apparition of new ones. Parasitic and bacterial diseases are the cause of important losses in pig farming, with an increase in mortality and a decrease in productivity and reproductivity on the farms. For example, a common disease in pigs is caused by the bacteria Escherichia coli. The colonization of the small intestine of animals by some strains of E. coli is typically the cause of severe diarrhea and dehydration. Moreover, there are a lot of antibiotic-resistant strains of E. coli, which make them even more dangerous. Studies on farms, which are the first part of the PPILOW research on phytotherapy, showed that E. coli was one of the most present bacteria on the studied farms. Indeed, it amounted to 72% of the identified bacteria. Pigs are also commonly infected by parasites like the one of the Eimeria genus, or Ascaris. Parasites of the Eimeria genus are the cause of coccidiosis, which affect weaners and fatteners. It can influence the growth rate of weaners and manifest through diarrhea and weight loss. Ascaris, on the other hand, has a low to moderate effect on the health and productivity of animals, but contamination by this parasite can lead to an increased contamination by bacteria and virus as well. Infection of humans through the ingestion of food contaminated with eggs is also possible. The studies on the use of phytotherapy were focused on 6 different medicinal and aromatic plants commonly grown in Romania: garlic, Allium sativum, wormwood, Artemisia absinthium L, coriander, Coriandrum sativum L, pumpkin, Cucurbita pepo L, summer savory, Satureia hortensis L, and marigold, Calendula officinalis L. After identifications of common pathogens on farms, in vitro tests were performed on the 2 types of parasites, Eimeria and Ascaris. The first in vitro study covered the anti-parasitic action of these 6 plants on the Eimeria genus parasites. The efficiency of alcoholic plant extracts was compared to the action of ethanol used as control in these tests. The effects of alcoholic plants extracts were found to be superiors to those of ethanol alone, which already has a good disinfectant activity. Of the 6 plant extracts, alcoholic garlic extract showed the strongest effect on the Eimeria genus parasites, demonstrating a good activity at all dosages, both destroying the oocysts and inhibiting their sporulation. In second place, after garlic, was the alcoholic plant extract of wormwood. The second in vitro study also covered the anti-parasitic action of the 6 plants, but this time against the parasite Ascaris. All tested plant extracts showed anti-parasitic effects on the development of Ascaris eggs that increased with the concentration used. Like in the first in vitro study, garlic was the most effective extract, with wormwood the second best of the 6 tested. These results show that these 6 plants, especially garlic and wormwood in these cases, may be viable alternatives to antiparasitic drugs currently used on farms. Once the in vitro tests were completed, several in vivo tests were conducted on different farms. 3 experiences with similar methodologies were conducted with the different plants to assess their antiparasitic potential on digestive parasites of swine. The plants used were the same 6 than during the in vitro tests. To conduct the experiences, 3 experimental groups and 3 control groups of swine were dosed with the different plants for 10 days. Garlic and wormwood revealed a strong antiprotozoal activity, while pumpkin and summer savory showed the strongest anthelminthic activity. These 4 plants therefore have potential for the treatment of gastrointestinal parasites in swine without use of conventional antiparasitics or antibiotics. The alternative to antiparasitic and antibiotics offered by the use of plant extracts or plant powder included in the feed could be a way to reduce the use of such drugs. This would in turn reduce the development of resistant strains and help fight them. Its use would also be particularly helpful in organic agriculture, in which the use of chemicals is prohibited.